Meniere's disease, a multifactorial disorder of the inner ear, is characterized by severe vertigo episodes and hearing loss. Although the role of immune responses in Meniere's disease has been proposed, the precise mechanisms remain undefined. Here we show that downregulation of serum glucocorticoid-inducible kinase 1 is associated with activation of NLRP3 inflammasome in vestibular resident macrophage-like cells from Meniere's disease patients. Serum glucocorticoid-inducible kinase 1 depletion markedly enhances IL-1 beta production, which leads to the damage of inner ear hair cell and vestibular nerve. Mechanistically, serum glucocorticoid-inducible kinase 1 binds to the PID domain of NLRP3 and phosphorylates it at serine 5, thereby interfering inflammasome assembly. SGK negative down mice show aggravated audiovestibular symptoms and enhanced inflammasome activation in lipopolysaccharide-induced endolymphatic hydrops model, which is ameliorated by blocking NLRP3. Pharmacological inhibition of serum glucocorticoid-inducible kinase 1 increases the disease severity in vivo. Our studies demonstrate that serum glucocorticoid-inducible kinase 1 functions as a physiologic inhibitor of NLRP3 inflammasome activation and maintains inner ear immune homeostasis, reciprocally participating in models of Meniere's disease pathogenesis.